Let's go.
Hello everyone, you are welcome to my channel. Here is 2023 NECO Physics past question solution series objective, and today we are going to start from question 36 to 40. If you have been following us, we've done from 1 to 35, and today we're going to be looking at 36 to 40. So question 36 says figure 3.4 represents a horseshoe magnet. If it is dipped in a plate of iron filling, which points labeled 1 to 4 on the magnet will the filling concentrate mostly? So here is the pole, here could be north and here could be south. So the power of the magnet is more at the pole than other part of the magnet. So here is where the iron filling will be concentrated most. So that is 1 and 4. So let's look at the option. You have option A, 1 and 4, 1 and 5 only. Option B says 1, 3 and 4 only. So let us not waste our time. The correct answer is option A, 1 and 4 only, 1 and 5 only. Are we clear? So question 37 says, what is the function of the split ring in a DC generator? In a DC generator, the split ring is used to reverse the direction of the current such that the output will only flow in one direction. So that is DC, direct current. So the correct option here is option D, to reverse the direction of the current. In AC generator, we use slip ring instead of split ring commutator. Please take note of the differences. So question 38 says, permanent magnet and electromagnet in use. I have force, Roman figure I, the permanent magnet and electromagnet in use have force field around them, which is correct. They have poles, which is correct. Lose their magnetism easily. Here is only for electromagnet, which is a temporary magnet, easily magnetized and easily demagnetized. But permanent magnet take time to magnetize, and it also takes time to demagnetize. So they are used where we need a strong magnetic field for a long period of time, such as in generator. While the electromagnetic is used in a device where we need intermittent electric field, magnetic field rather, or electromagnetic field, such as in a doorbell. Are we together? So looking at this option now, the correct option here is going to be 1 and 2 only, because 3 does not apply to permanent magnet, it only applies to electromagnet. Are we together? So looking at the option, you have option D, which is 1 and 2 only. Are we clear? So question 39 is calculation. So the question says, calculate the instantaneous value of the current in a circuit which has the root mean square value of 14 amp and a phase angle of 40 degree. So you should remember, each question you should be able to determine the topic, that is alternating current. So we have this instantaneous current I is equal to the peak current I naught sine omega theta. So our omega theta is the phase angle and it is given to be 40 degree. Are we together? So you're looking for I, the instantaneous current here. So but what we are given is the root mean square value, of the current, which is given to be 14 amp. So we need the peak value current in order to get the instantaneous current. So therefore we think about the relationship between root mean square and the peak value current. So we have that the root mean square is equal to the peak value all over root 2. Is that correct? So which implies that the peak value current is equal to the root mean square value multiplied by root 2. So doing that, what is the root mean square value? Is 14 multiplied by root 2 when you press your calculator, do 2 multiplied by 14, that should give us 19.798 amp. Are we clear? So when you are done with this, then you come back to the relationship between the instantaneous current and the peak value, right, which is sine omega t. So from here we can now say that peak value is given to be, I found it to be 19.798 multiplied by sine omega theta is 40 degree. So when you multiply sine 40 degree by 19.798, that should give us 12.7 amp approximately. So that is option what? That is option C. So that is option C here. So 12.7 amp. So the next question is question 40. Question 40 says a RC, that is resistor capacitor series circuit, right? So we have resistor capacitor series circuit has a resistor of resistance 30 ohms and a capacitor of capacitive reactance of 40 ohms. If an alternating voltage of 220 volts, 60 Hz is connected across the circuit, calculate the current passing through the circuit. So question 40, here we are given that the resistor R is equal to 30 ohms and the capacitive reactance, which is XC, is given to be equal to 40 ohms. So then from there we are also given that the voltage is equal to alternative voltage given to be 220 volts and the frequency is said to be 60 Hz. Is that correct? So we are looking for the current, but since it is a combined combination of two components, resistor and capacitor, so we are going to find the resistance offered by the combined effect of resistor and capacitor, which we call impedance. So impedance Z is equal to root of R squared plus the capacitive reactance squared. Are we together? So that will give us root of R is going to be 30, that will be 30 squared, plus XC is going to be 40, we have 40 squared. Then we have it to be 30 squared is 900 plus 40 squared is 1600. From here I'll have root of 2500. Is that correct? So then find the root of it. That should give us 50, right? 50 ohms. So we have gotten our 50 ohms. Remember, from Ohm's law we have V is equal to IR. Had it been it is just resistor, we have this. But since it is a combination of the resistor and capacitor, instead of R, we are going to have V is equal to IZ, which is a combined opposition offered by the what? Resistor and capacitor. So from here we're looking for the current. So we have I equal to V all over Z. So what is our V? That is 220 volts all over Z, which is the impedance, that is over 50. So when you do the division, your I should be equal to 4.4 amp. 4.4 amp. I hope you understood and you enjoyed this class. So we are going to stop here in today's class. In our next class we continue from question 41. Thank you for the time and thank you for watching. If you are new to this channel, please ensure you subscribe to my channel so I can give you some more visibility. Thank you. God bless you. See you in the next class.